All right. Hello, future math teachers. My name is Brent Bauman. I want to go over the NES Secondary Ed Mathematics Measurement and Domain and Geometry. Sorry, this is Domain 3. So let's go ahead and dive into this one and we'll look at what's in Domain 3 to start with. So there's three different parts to Domain 3, so we'll have a video for each. The first one, what we're going to look at in this video is understand measurement principles and procedures. So let's go ahead and look at what that means. So remember, with each part of the domain, you get some more detail on topics that you can study. So this will give you just um, an idea of concepts that you can go look at and try to remember um, what you're working with. So let's go ahead and look at this one. And we're going to start with our first guided practice. I'll give you a second to read through this. Okay, so hopefully you look through and you're identifying that we're dealing with the volume of a cylinder. And on your reference sheet, when you're working with the exam, it gives you the formula in this form. Volume equals capital B times H. So B is referring to the base of whatever you're working with. So if you think of a cylinder, we're dealing with a base that is a circle. So what we need to do is we need to remember that our base has an area of pi r squared. So really our formula for the volume of our cylinder is pi r squared times h. And notice that they gave us a radius as well, so that's a good idea that we're going in the right direction. So let's go ahead and plug in our part and see what we get. So we have volume is equal to pi times r, which was, r, which was given as 3 squared times h. So we go ahead and do what we have so far. So 3 squared is 9 times 10 is 90 pi. We have volume. And then we look at our answers. We have 60 pi. We have 100 pi. We have 94.25. And we have 282.74. So these ones are close, but they're not quite there. 94 is not there. So if we remember that pi is about 3.14 times 90, so 3 times 90 is 270 plus the 90 times 0.14 will get us to this answer of D. And you'll have a calculator that you can go ahead and multiply them out. Another thing I would say to be careful with is units. So these are meters. So you get your meter squared times your meter, which gives you the cube. So just be careful if for some reason they have same answers with different units. Okay. So maybe a part of this is look at the reference sheet and see if it is detailed enough for you, or if you need to look into, well, what does this B really mean in this formula they're giving me, and do a little studying on that so that you're ready for the extra parts that you need that are not given to you on your study sheet. Okay. Look at a couple on this slide. Here's the first one. Um, I'll give you a second to go ahead and read it. Okay. So we have a triangle. We can go ahead and draw it real quick if you want. And again, it won't be to scale. You can try to make it to scale. And we're trying to figure out what type of triangle it is. So again, these are definitions you're going to need to know, the acute, obtuse, when you were dealing mostly with the angles type of problems you'll probably see, is I would assume they'd be angles and asking you about acute and obtuse. Equilateral is talking about the sides being the same, the angles being the same. So that's not what we're working with here. And the right one is probably the most common one. Um, and it's dealing with, you can check to see if there's a 90, which we're not given that there's a 90. So that's not something we can use. But we also have the a squared plus b squared equals c squared is going to happen if it's a right angle. So we can just check that real quick to see if that gets us there or gives us a true statement. So we have 6 squared plus 8 squared equals 10 squared. So 36 plus 64 equals 100. And that's a true statement. So we can say that this is a right triangle. Again, just refresh on the different types of triangles, their properties with their angles, their sides, those types of things, so you're ready to classify different triangles. Another one to just, again, just a topic to go back and think about a little bit more. I'll go ahead and let you read this real quick. So this is sort of just not necessarily specifically crunching any numbers or anything like that, but it's thinking about some of the tools that you've used as you work through some of your math classes. So it's talking about the thickness of a hair. So if we look at our options, ruler, measuring tape, those are going to be pretty hard to use for thickness of a hair. Thermometer, going to give us the temperature. And then we have a caliper, which measures, you can get them pretty fine there. So that would be our best option. So it's just, again, just more of a reminder to think about some of these tools and just maybe refresh on them. Okay. Let's look at one more for this video. Okay. So with this one, we're dealing with, I'll let you read it for a second. All right. So with this one, we're dealing with converting. You have different types of measuring how much water you have. So it's telling us that we use about 0.86 acre feet of water every year. That's what we're starting with. That's the initial quantity. And we're trying to figure out how many 5-gallon bottles would we need. So we need to go from 0.86 acre feet to a number of bottles. And we're given some information here. So you may not always need everything that's given, but we're given some information here. So we definitely want to check on those as we go through. But we're dealing with a conversion. So conversions can be set up a little different. The way that I like to work with them, find my mouse, is we'll write down what we're starting with. So we are starting with 0.86. I'm going to use A for acres and feet, FT for feet. And we're trying to get to uh, number of bottles. Okay. So if we're trying to get to bottles, that's our final units, and we're starting with acres and feet, these eventually need to reduce out, and that's where our givens are going to come into play. So we have 1 acre equals 43,560 feet squared. Okay. So that would help us reduce an acre if we wanted to get the A out, but it would give us more feet. So we'd end up with a feet cubed because we already have a feet here. But if you look at your next conversion, you can get rid of the feet cubed and get to gallons. Okay. And then gallons can be changed into bottles. So it looks like our full path is given to us here. So we just need to make sure that we set everything up correctly. So we're going to set up so that our 1 acre cancels. And up top, we have 43,560 feet squared. So we could write this ratio either way, but we want to make sure that we set it up so that we get some reducing going on. So hopefully you're seeing that when this step, we're going to get rid of the A's, the acres. So now we're just dealing with feet. And our path is to eventually get to bottles, but before we can get to bottles, we need gallons. So gallons can be converted if we have feet squared. But again, if we look, we have feet times feet squared. Sorry, we need feet cubed. So we have feet times feet squared, which will give us feet cubed. So we're actually at feet cubed now. So let's go ahead and set up our next ratio with feet cubed in the denominator. That means the 7.481 gallons has to be in the numerator. And that's going to work out good for us because this feet cubed is going to reduce the feet and the feet squared that we have. So now we're only left with gallons and we're trying to get the bottles. So we have one last ratio to set up and we have 7.481 gallons per 1 bottle. So our bottles in the numerator, which is what we want number of bottles. Our gallons going to reduce here. And we're left with 0.86 times 43,560 times 7.481 times 1. We don't need that. And in the denominator, we're left with looks like, oh, I made a mistake here, didn't I? Okay, so it's 1 bottle per 5 gallons. We're using this last one. Sorry about that. So we have 1 bottle per 5 gallons. So we're dividing this by 5. Okay. So again, go ahead and use your scientific calculator to calculate this out. And we should be getting 56,050. I think it's I did it earlier, 0.05. So that gives us 56,050 bottles of water. Okay. So a little conversion to work with. Again, these are sort of like puzzles. You want to get those units to cancel out that you don't need, and hopefully they get you towards the units that your final answer is wanting to be. So I would suggest setting it up if you've done conversions a different way and it works. Use your method. All right, I hope that was helpful, and we'll see you in the next video.